This is the Vera C Rubin Observatory, high in the Chilean Andes. Inside it lives a monster of a camera, the LSST Camera. It has 3.2 gigapixels, 189 CCD sensors, and an 8.4-meter mirror collecting light from the sky. Every exposure lasts just 15 seconds. Then, 30 seconds later, Rubin looks again. Snap 1, snap 2, same patch of sky. But when the shutter closes, Rubin does not get a beautiful astronomy picture. Not yet. It gets billions of raw electrical clues. The focal plane is not one giant sensor. It is 189 separate CCDs, arranged like a circular mosaic. Each CCD is split into 16 amplifiers, so more than 3,000 tiny electronic channels read out at the same time. Instead of one clean image, Rubin gets around 200 separate FITS files from every exposure. Think of it like a giant space jigsaw puzzle dumped onto the floor. A pixel might say 3,482 ADU, but that does not mean 3,482 photons. It just means one amplifier measured that much voltage, and every amplifier speaks a little differently, so this is where the story gets messy. Those files are not ready-made science. They are fragments. Each one comes from a different part of the camera, with its own noise, offset, and sensitivity. Before Rubin can ask, what changed in the sky? It first has to ask, what did the camera actually measure? Because right now, the data is basically saying, I saw something. And Rubin is asking, okay, but how much of that was actually space? Here is the brutal truth. Every raw pixel is messy. Not a little messy, properly messy. Electronics at a fake starting level before the shutter even opens. Even in darkness, the silicon creates tiny thermal signals. The camera is cold, but it is not magic. The telescope optics also make some pixels brighter or dimmer than others. Some corners are darker. Some pixels are extra sensitive. Dust can leave little shadows. And then cosmic rays barge in. High-energy particles punch through the detector and leave bright streaks that are not stars. Space is rude like that. Add crosstalk, gain variation, saturation, and amplifier quirks, and now you have the full chaos. A raw pixel is not just the universe. It is the universe mixed with electronics, temperature, dust, and a bit of drama. Now the Rubin science pipelines take over. Their job is simple to say and very hard to do. Turn the messy electrical puzzle into a science-ready image. First, overscan subtraction removes the electronic starting level, then dark subtraction removes the fake thermal glow. Flat field correction adjusts for uneven pixel sensitivity. Gain conversion turns amplifier counts into physical photoelectrons. Cosmic ray rejection spots one-frame troublemakers. If something appears in only one snap, the pipeline gets suspicious. Finally, the separate pieces are stitched together. Around 200 raw segments become one clean 16,000 by 16,000 science image. Now the sky is ready to be searched. Rubin compares the new image with an older reference image of the same sky. Same stars, same galaxies, same patch of universe. Subtract the old sky from the new sky, and anything that changed lights up. A new dot, a fading dot, a moving dot. When the pipeline finds a significant change, it creates a DIASource. That stands for Difference Image Analysis Source. It could be a supernova, an asteroid, a variable star, or something stranger. For each DIASource, Rubin builds an alert packet. It includes the position, brightness, change in flux, a real bogus score, and tiny postage stamp images. Tiny file. Huge meaning. It says, something changed here. Look now. The alert packets do not sit quietly on a server. They are broadcast in real time to the astronomical community. Alert brokers receive the stream and sort it for different science goals. ALeRCE classifies events. ANTARES searches for multi-messenger connections. Fink looks for anomalies. Lasair helps astronomers find and follow up transients. On a clear night, Rubin can generate up to 10 million alerts. Each one started as light heating silicon. Each one became a tiny message from the changing universe. 15 seconds of photons, 60 seconds of processing, a universe full of change delivered live.